So we're continuing with a substitution method, and this time around we're looking at some integrants that are not quite obviously the derivative of outside evaluated at inside times the derivative of inside. So example 6. How do I go about doing this one? I still I see a product rule. I mean, not product rule. I see a product, and looking at that, what I notice is that what I would assume inside function t plus 1 is not going to be, the derivative of that is not t plus 2. But then what happens is that I don't see any more complicated things going on. So my first try is to assume that t plus 1 is the inside function. And then du is going to be equal to dt. And then replacing it back in here, so this is going to be u to the power 1/4 and times du. What's going to happen to t plus 2? Then I manipulate a little bit algebraically, and I realize t plus 2 is just t plus 1 plus 1. So it would be u plus 1 is equal to t plus 2. And or the other way around to go about this is to solve for t and then replace back in terms of u and replace back. But this one is very obvious, so I didn't even do that. And so over here what I get is u plus 1 times u to the power 1/4 du. Now, this is a little less complicated, but still looks like a product. But it's a product that I can manage using algebra. So that's what I do. So I basically distribute the u to the power 1/4, and I get u to the power 3/2, 1/4 plus 1 is 5/4. Yes, 5/4 plus u to the power 1/4 du, which is going to give me u to the power 9/4 times 4/9 plus u to the power 5/4 times 4/5 plus c, and replace it back. 4/9 t plus 1 to the power 9/4 is 4/5 of t plus 1 plus c. So I made it a little less complicated, and basically what we're doing, we're changing the integrand so we can guess the antiderivative, and that's how every time it works. Let's do one more example. This time around, the integrand is x to the power 3 and square root of x squared plus 4. Again, if I assume u is equal to x squared plus 4, du is going to be 2x dx, and it's not quite there. And I still have a product, so I have to do something about this. What I noticed here this time is that, well, I can regroup things. I can regroup x to the third as x squared and x dx. So x dx over here will give me 1/2 of du. Then x squared itself can be solved over there. X squared is u minus 4. So what I end up with is u minus 4, u to the power 1/2, du times 1/2. And 1/2 I brought it outside. So it would be 1/2 of, again, distribute, because again it's a product and I need some algebraic manipulation. U to power 1/2, U to power 1, U to power 3/2, minus 4 U to power 1/2 du, and so it's 1/2 U to power 5/2 times 2/5 minus 4 U to power 3/2 times 2/3 plus C. So going over the same example, we choose the u to be x squared plus 4 and du becomes 2x dx. The x dx is not quite apparently in there, so we have to kind of regroup stuff, and what we end up with is we put x squared in one side, 2x on the other side, and then we have to remember that there has to be a 1/2 in there also, and so we end up with this type of things. Distribute through, take the antiderivative, and then you end up with this antiderivative after you substitute back. Now I click here question 5. Consider the indefinite integral x times 2x plus 7 to power 8. Which of the following integrals is equal to, and to it by substitution method. Okay, I'll let you work through it for a minute and come back. Now let's see, in here I see that the complicated part is that part, but then derivative of that part is just 2. The inside function of that part is 2, and at this point I will still try though. So I put in u equal to 2x plus 7, and then du is going to be 2dx, and so therefore dx is equal to 1/2 of du. This becomes integral, I have to solve for x. How do I solve for x? Over here, x is equal to take u to the other side, divide by 2. So x is u minus 7 divided by 2. 2x plus 7 to power 8 is u to power 8, and dx is 1/2 of du. So together they become 1/4 u minus 7 u to power 8 du, which is this part.